Where are we? Electron emitted in nuclear beta decay, positron decay, gamma rays, surface tension. A constant used in relativity, change in whatever quantity flows, uncertainty in whatever quantity flows. Change. So this triangle represents change. Change in energy between the initial and final orbits of an electron and an atom. Uncertainty in energy. Really? The same symbol. Okay. Change in M. Difference in mass between initial and final products. Change in N. Number of decays that occur. Change in P. Okay, we want to look for something very specific. We're looking for distance. 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 Lambda. Displacement. Is that... I don't think distance is in... Hold on. Okay, let me look up. Okay. How do you... Okay, but actually, let's go to ChatGPT here. We are allowed to use it. ChatGPT. So, go to ChatGPT. And let's start now. Yeah. Okay, so... how do you define distance in physics? No, what is the equation of distance? What is the equation of force times distance being work? Okay, so how to write the equation of force or of work, which is force times distance. How to write the equation? Yes, okay, so this is a little d. Okay, but if you go back, you know that the little d stands for something else. Isn't it like displacement? I mean, I guess that is distance? What? Okay. Define displacement. Define displacement. This vector quantity describes the change in position of an object. It is defined as the shortest straight line distance between an object's initial and final positions along with a specified direction. Key characteristics of displacement include magnitude. The straight line distance between the starting points and ending points, direction, the direction from the initial position to the final position, vector nature, displacement has both magnitude and direction, distinguishing it from distance. Distance? Wait, is that? Yeah. Vector nature, displacement has both magnitude and direction. Distinguishing it from distance, which has a scalar and only has magnitude. So I think this is the equation. I wrote it here, so, but the only problem here is that I wrote capital, so maybe it's like that. Maybe it is like that, okay? So, alright. So, we have here work times force. Oh, Doris, what's wrong with me? Force times distance. Work times. What is wrong with me? Oh my god. Okay. Equal. Pay attention. Ava, pay attention. Oh my god. What is up with you? Jesus Christ. Gotta make this bigger here. Maybe I'm supposed to be doing artwork right now. Hold on. 36. There we go. Okay, let's go back to the physics book right now. Here we go. Work, energy and energy resources. We define work as force times distance and learn that work done on an object changes its kinetic energy, right? So, let's write that down. When work is done on an object, it changes its kinetic. What is... I'm a Blender user, and I know about kinematic bodies, right? I'm over here writing connective. What is... I don't know where my brain is today. I should have already known how to spell this. Kinetic. And there's kinematic bodies, you know. Actually, that's something in game physics, but never mind. I don't even know a lot about game physics. Or I should study it. Anyways. I know some stuff, but I don't know all stuff. Kinetic... What? What do we do? What? Kinetic energy. Okay. Kinetic energy. I can't type. Okay. Work is done on an object. When work is, it's just like, okay. So we define work as force from systems and learn that work done on an object changes its kinetic energy. So work done. Okay, we have that. Cool. We also saw in temperature, kinetic energy, and the gas laws. Keep in mind, I did not read that chapter. That temperature is proportional to the average. Temperature is proportional to the average kinetic energy of atoms and molecules. Average. Proportional. Average kinetic energy of atoms and molecules. Okay. Okay, so we're gonna write down here. Temperature is proportional to the average kinetic energy of atoms and molecules. Average. Temperature is proportional to the average. We say that a thermal system has a certain internal energy. Okay, so we're going to write thermal system. Thermal system. There we go. We see that a thermal system has a certain internal energy. Its internal energy is higher if the temperature is higher, so. I am so freaking itchy. What's up with me? So, the temperature is proportional. Its internal energy is higher if the temperature is higher. What? No, that's backwards. It's internal. Well, actually, that works. If the temperature is higher, then the internal energy is higher. If two objects at different temperatures are brought. So if two objects at different temperatures are brought in contact with each other. I'm so itchy. Jesus Christ. If two objects at different temperatures are brought in contact with each other. Energy is transferred from the hotter object to the colder object. objects at different temperatures are brought in contact with each other. Energy is transferred from a hot object to a cooler object until equilibrium is reached, and the bodies reach thermal equilibrium. No work is done by either object because no force acts through a distance. Really? No force? I'm not going to overthink it. The transfer of energy is caused by the temperature difference. Transfer of energy is caused by the temperature difference. And ceases once the temperatures are equal. These observations lead to the following definitions of heat. Definition of heat. Heat is the spontaneous transfer of energy due to a temperature difference. Okay. Heat is transfer of energy due to temperature difference. As noted in temperature kinetic theory and gas laws, heat is often confused with temperature. For example, we may say that heat was unbearable when we actually mean that the temperature was high. Heat is a form of energy, whereas temperature is not. So temperature and heat are different things. The misconception arises because we are sensitive to the flow of heat rather than the temperature. Owing to the fact that heat is a form of energy, it has the SI unit of joule. The calorie, CAL, is a common unit of energy. Owing to the fact that heat is a form of energy, it has the SI unit of joule. Okay, the calorie, CAL, is a common unit of energy, defined as the energy needed to change the temperature 1 gram of water by 1 degree Celsius, specifically between 14.5 degrees Celsius and 50.5 degrees Celsius, since there is a slight temperature dependence. Perhaps the most common unit of heat is the kilocalorie. Owing to the fact that heat is a form of energy, it has the SI unit of joule. Alright, so we say heat. Heat is a unit of joule. Joule. Did I spell that? I did. I actually did. Wow. But let's just lowercase it. Joule. Okay. The calorie. See, that was a common unit of energy. Okay. Calorie is cal. Well, wait. Calorie. Cal. Okay. It's a common unit of energy defined as the energy needed to change the temperature. My legs. Ow, I'm in pain. It's hard. It's a common unit of energy defined as the energy needed to change the temperature 1 gram of water by 1. Specifically the too much info. Here we go. Okay, so energy defined as the energy needed to change the temperature. So calorie is a common unit of energy defined as the energy needed to change the temperature of 1 gram of water. Defined as the energy needed to change the temperature